Hello, I've had a question in Unit 3, Lesson 13. I'm looking at 7a, and they want us to find the second derivative by implicit differentiation. So at first it looks all right because it's going to be a power rule question, but unfortunately it always becomes challenging when you have implicit. So let's go ahead. We can take the derivative immediately, and we end up with 4x cubed plus 4y cubed. Now remember, every time you take the derivative of a y, you have to have a y prime, and just be careful that you don't see it as a value of y equals 0. Now, you can do this a couple ways. I would recommend solve for y prime, isolate y prime. So 4y cubed, y prime equals 4x cubed. Oops, it'd be a negative. Divide both sides by 4y cubed. And if you do that, 4's will cancel. So we get y prime equals negative x cubed over y cubed. Now we want to take the derivative of that. So, continuing on my way here. You can do this a couple ways. You can use product rule. If you've watched some of my earlier videos, I'm not a big fan if we can avoid the quotient rule. So what I'm going to do is I'm going to rewrite it as y prime equals negative x cubed y to the negative 3. So that exponent, when I move that term up to its numerator, the exponent will change. So it becomes negative 3. Now it's a product rule. So the second derivative, y prime, is equal to, take the derivative of the first function. So there's two functions here. 3x squared, y to the negative 3, plus the first function, negative x cubed, multiplied by negative 3, y to the negative 4 times y prime. Okay, so here's where we need to do a little bit of substitution to clean things up. So the first one is straightforward. It's going to be negative 3x squared on top over y cubed. All right. Now I have two negative signs here that will cancel each other out. I have a 3 and an x cubed and a y prime that's going to stay on top. So it's going to be 3x cubed y prime over y to the 4th. And you got to be careful. These do not cancel. This is why the only thing I don't like about this notation, that's a y prime. We can't have y prime in our final answer. So what we're going to do is we're going to do a substitution. I know what y prime is equal to. It was up here earlier. So I'm going to bring it down. I'm going to replace that value right there. So now it becomes negative 3x squared over y cubed plus 3x cubed. And in the brackets, we get negative x cubed over y cubed. And that's all being divided by y to the 4th. So at this point, we've taken the derivative successfully. So all we need to do is, I'll show you the algebra simplification to get the answer they did. So again, I'm going to leave this first function alone. Plus, now this second function, we're going to end up in the denominator. This y cubed is going to go down there, so we're going to end up with y to the 7th in the denominator. And on top, we've got 3x to the exponent 6, and that becomes subtracting now because of that negative sign right there. All right, on top I can factor out actually, before factoring, I'm going to get a common denominator. Probably the easier step there. Oops, too far back. So the common denominator will be y to the 7th. That means that first term is going to need a y to the 4th minus 3x to the 6th. That one already had a y to the 7th. Now on top, I'm going to take out a negative 3x squared, which will leave me with y to the 4th plus x to the 4th over y to the 7th. And if we go way back to the original question, oops, where's the original question? We see that x to the fourth plus y to the fourth is 1. So again, we go way down here again, and we see that x to the fourth, y to the fourth, well, that's just equal to 1 based on the original equation. So it becomes kind of a circular process in some ways because we're going back using previous information. And the final answer then is negative 3x squared over y to the 7th. And that is your final answer. Really, again, I'm looking at your process, how to get it, what the derivative will be. So I'm looking at basically this step here. 95% of your mark occurs. The only time you go beyond this point is when you have a word question that you want to take a step further. But for myself, if I'm just asking for a derivative, that's kind of where it would have ended for me. If you have any questions about this one, let me know, and I'll see if I can clarify it further.